This is Algebra 1, Semester 2. It's the third unit called Quadratics. It's the third lesson called Factoring x squared plus bx plus c practice. It's in Creator Math under the Algebra tab. Here are the directions. Copy the following problems. Hi, Brian. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. Don't forget the notes, you guys. That's a separate link on the table of contents for the correct pages in the comp book, of course, under creatormath.com, under the Algebra tab, under the table of contents. Make sure it's Semester 2 table of contents too, by the way. This one just says factor the following polynomial completely. So polynomial means, poly means many, and nomial means term, basically speaking. So this is a multiple term. Actually, it could also be called a trinomial, tri meaning three, so trinomial or polynomial. There's three terms to this one, and it factors back into our binomial times a binomial. Binomial is a two-term statement here, or expression, and a two-term statement here. So multiplying two binomials is a 4 multiplication step, hence why it's called a quadratic, because it's got 4 in it. But it simplifies down to, when you combine like terms, it simplifies down to a trinomial, because two middle terms simplify. So there's a couple ways to do this. This is Algebra 1, so we're going to deal with simple problems. We have another one, we have a term up front, that's the next lesson. This one, we're looking for what two numbers, when multiplied together, produce a negative 27, and add to produce, and add together. So look, here's what I'm trying to say. When we multiply this together, let's multiply these. Negative 3 times a... So if I can back up a little, not starting very good here. If I just did FOIL on this, I could go through all 4 of these and do FOIL, right? I can go reverse since they give me answers. First, outside, inside, last. That, right? So x times x would be x squared. Outside is plus 9x. Inside is minus 3x. And last is minus 27. Then I combine these two, because we can combine like terms. 9x minus 3x is 6x. Minus 27 comes down, and the x squared comes down. And it matches up here. So that's the one we have. That one works, right? We're looking for what two numbers multiply to equal this. I call it the tail. It's the last term of the statement. And then add to be this middle term. So here are some options. If we multiply together to get negative 27, a negative 3 times a 9, a 3 times a negative 9, right? This is negative 27. Let's check, because it gets this. This is equals minus 27. I'm going to go slower on this first one, then faster on the others. But I also need these two terms to add to equal the middle term. So if you add 9 plus negative 3, you do get 6. So I know this is the right one. These are the two. And what we do is drop them into a statement of two binomials. We know we have an x and an x. We know we have a minus 3, so that goes here. And we have a plus 9 here. Done. That's called factoring. So factoring is the reverse of distribution property. We use the FOIL method in this country for whatever reason. I'm not sure why. Distribution is a better way to do it. However, this is the right answer here. All right, so without getting too bogged down, you're going to see a pattern to these. Let me try to keep going so you can see the pattern. What two numbers, when multiplied together, equal 48? Well, I like 6 times 8 is 48, right? Now, I have a negative on this 14, so I need it to add to be negative 14. So if I took 6 times 8, that is 48 when multiplied. And then if I add them, I do get 14, but it needs to be a negative 14. Well, what if I multiply negative 6 times negative 8? That still equals a positive 48, and that matches there. And if I add it, I get a negative 14. So these are my two values here. Set up two binomials. This one's easy because there's no initial coefficients here on the x's. They're just x and x. We have a minus 6 that goes into one and a minus 8 into the other. X minus 6, x minus 8. What two numbers, when multiplied, equal 45, yet added equal 14x? Well, let's see. How about 9 and 5? 9 times 5 is 45, right? So 9 times 5 equals 45, and that's positive. But if I added 9 and 5, do I get a positive 14? A negative 14? No, I get a positive 14. So the same situation, if I did multiply a negative 9 times a negative 5, that would have still given me a positive 45, and when I add it, I would have gotten that negative 14. So set up two binomials, put in an x and an x. This is a minus 9 drops here, and a minus 5 drops in here. X minus 5, x minus 9. Doesn't matter which is first, right? I put minus 9 first and minus 5 second. I could have easily put x minus 5 first and x minus 9 second. When they multiply, it's the same thing. All right. Let's keep going. You will see a pattern. What two numbers when multiplied together equal 42? Well, 6 times 7 does. That equals 42 when multiplied. So I like 6 and 7. If I add them, do I get 13? Yeah, I do. So it's a positive 6 and a positive 7. I can go straight here. I can go x plus 6, x plus 7, x plus 6, x plus 7. Factoring. I could have also started here and gone forward like I showed you in the initial problem. Let's see number 5. This one's here. Sorry about that. So z squared plus 8z plus 15. What two numbers when multiplied together equal 15 and then add to be positive 8? Well, 3 times 5 is 15. All right, and when I add them, do I get 8? Yes. So I get x plus 3 and x plus 5. X plus 3, x plus 5. Whoops. I always change it to x's, you guys. I'm sorry. Z, z. Z plus 5, z plus 3. The reason I don't use z's is because mine start to look like 2's. Then I try to put a line through them, and then students are like, what are you trying to write there? So I often will just switch everything to x's because it's easier when I start to write it. All right, this one is what two numbers when multiplied together equal 40 and add to equal negative 13. We have to match the sign too. Well, I mean 40, some of the things could be 4 times 10, right? But that when added, you'd get 14. So that doesn't work. I mean, and I can also start to look down at these answers, you guys. Isn't 5 times 8 40? And if they were both negative, wouldn't they add to be a negative 13? So a negative 5 times a negative 8, sure enough, equals a positive 40. That matches the tail. And if I added them, I would get a negative 13. So I'm going to get x minus 5 here. That's going to be one binomial, and x minus 8 is going to be another. And how do you check it, you guys? Go backwards, right? First, outside, inside, last. First is x times x is x squared. Outside is negative 8 times x. Negative 8 times x is negative 8x. Inside is negative 5 times x. And last is negative times negative positive 40. These combine. That's why you're asking that question, but add to be this middle term, right? Because that's how that's generated in the original 4 multiplication steps that produce a quadratic. Quadratic is anything with a power 2 on it and below. Not and below, with its higher power, a power 2, right? That is a quadratic. So this right here is technically a quadratic, right? Because it's to the power 2. And it produces a parabola graph, by the way, which we'll get into later when we do more of these in the quadratic unit here. Right, so these add negative 8 and negative 8 is negative 13x, just to finish up. And sure enough, this is right back to where we started. So just like math, we're doing a forward and a reverse. Factoring is the reverse of the distributive property. So factor the following polynomial completely. Here it is. What two numbers when multiplied together equal negative 63? So how about a negative 7 times a 9? That equals negative 63 when we multiply it. Does it add to be 2x? Well, I got lucky here. 9 and minus 7 is a 2, so this is it. It's just the first one I tried. X minus 7, x plus 9, match it up. X plus 9, x minus 7, done. Factor the following polynomial completely. Again, what two numbers when multiplied together equal a negative 63? Well, we just did one of these. We used negative 7 times 9 equaled a negative 63. But when we added these, we got a positive 2x. So here, when we did it, when we added these together, we got a positive 2x. Here, notice we have a negative 2x. Well, let's reverse the negative. Let's say a positive 7 times a negative 9, which sure enough still produces a negative 63, which is the tail. But when you add negative 9 plus 7, you get a negative 2. That matches in this case. So we're going to have an x plus 7 in this case, times an x minus 9. And if we compare the difference in these two, how the sign switched, and we compare the difference in the sign here and here, we start to understand why this is happening. This is one of those practice sets where I think repetition does help your brain start to see the patterns and explain to you a lot of what's going on, where at first it might not be completely understandable.